Data Vault is designed to enable parallel processing as much as possible, so that very large implementations can scale out without the need for major redesign. Now we will look at the loading phases of Data Vault. It is a little bit different between Data Vault version 1.0 and 2.0. One of the biggest differences is while we are using the surrogate keys in 1.0 and hash keys are consumed in the 2.0. This means that the data warehouse key will now be a hash value and not an integer value generated by the ETL tool or the database. Hashes also provide an integration point to non-relational database management systems such as NoSQL. So let's understand our loading mechanism in the first version. First, we have to load all the hubs and create surrogate IDs for any new business keys. The second step is to resolve the links between the hubs and create surrogate IDs for any new associations. At the same time, we can also create all satellites that are attached to hubs, since we already created the surrogate keys for hubs and we will use it for the lookup. Because as you remember, in satellite we inherit the surrogate key columns from the parent hub. So once you have created all the new links with their surrogate keys, you can add the satellites to the all links. Since the hubs are not joined to each other except through the links, you can load all the hubs in parallel. Since the links are not attached directly to each other, you can load all the links in parallel as well. And since the satellites can be attached to only hubs and links, you can also load these in parallel. As you've seen that due to modeling approach of Data Vault as business keys in hub, descriptive attributes in satellite, and relationships in link, so all identifiers are separated out into different data storage layers, and that increases the parallelism of loading process a lot. But as you remember, it is a little bit different in relational databases, as all definitions, business key, primary key, foreign key, and attributes are all in the same table, and that provides dependency on the loading process. And finally, the respective dimensions and fact tables in information mart layer will be loaded sequentially. So we achieved quite big amount of parallel processing with the Data Vault. But still we have some extent of dependency, as the loading pattern for Data Vault 1 required to load hubs first, and later, when the links and satellites were loaded, make the lookups on the hub table to retrieve the surrogate keys. And on the other hand, problems occur with the links which is related to other links, because resolving the business keys in the link leads to another link that has to be resolved as well. Therefore, from modeling approach, we should avoid link to link on the models. But it still shows we have some degree of parallelism, and hash key helps us in here. In Data Vault 2.0, the surrogate keys are replaced by the hash key. Using the hash key can solve the issues with late arriving data, and more importantly, they can increase the load performance of the data model significantly. They enable to load the data fully parallel into the Data Vault model. So how it works? Hash key generator will create the same hash key value for a specified input each time in the same way everywhere in the system. Therefore, we don't need to inherit hash key values from a parent table. Think about the satellite. During the loading process, it needs to look up and inherit the hash key from the parent table. But if the hash key generator would give the same hash key result each time for the same business key, then there is not any lookup process required. So it would remove the key lookups for all hub, link, and satellites and the link satellite templates. So by this way, in Data Vault 2.0, you can load your data in even more parallel approach. This is because the key distribution bottleneck lookup is eliminated using the hashing concepts. You essentially don't have to do a key lookup for hub and link keys anymore. And that causes massive increase in performance while also reducing the complexity. So we get understanding that in Data Vault 2.0, the hub, satellite, and link can be loaded in parallel with the hash key approach. But this approach makes only sense when there is no referential integrity constraints. But what referential integrity means? Referential integrity refers to the relationship between tables, because each table in database must have a primary key, and this primary key can appear in other tables as foreign key. If you change or delete a row in one table, you destroy the meaning of rows in other tables. By default, the database server does not allow you to violate referential integrity and gives you an error message if you attempt to delete the rows from the parent table before you delete the rows from the child table. And additionally, it does not allow to add any record in the table that contains foreign key unless the reference table containing the corresponding primary key. Therefore, in relational databases, referential integrity constraint is a set in order to keep consistency between tables. But when we consider the big data platforms, for example, if you would like to store data in Hive database, there is not primary key, foreign key, or referential integrity is enabled in this platform. So one table does not need to check consistency with another table when getting a new insert. And that enables us, if we set up our data vault model on top of the database like Hive, which is very common in big data platforms, and in this database there is not referential integrity feature is enabled, then we would load our hub, link, and satellites in parallel. But if this feature is enforced in other relational databases, then you will have to load the hubs, links, and satellites in order. Now look at the flow, how we are going to load the hub tables. The concept behind hub load remains straightforward as shown below. So first we generate the list of distinct business keys. And if a business key in the list exists in the target hub, then we will drop this row from the data flow. For each remaining row with the distinct business key, we will generate a hash key using the business key as input. Then we will insert that record into the target hub. So it is quite simple and clear. So now look at how we are going to load the link table. The benefit of using hash keys was not quite obvious in the hub load, but for the link load, the replacement of each lookup with the hash key generation will serve to provide savings in the form of reduced input-output cycles. So the load pattern is shown below. First, we will generate the list of business keys and generate the hash key for each business key. And if the combination of hub hash keys exists in the target link, then we will drop this record from the data flow. So for each remaining row, it means the combination of hub hash keys, we will generate a hash key for link record by concatenating the hub hash keys and running the result through the hash function. And we will insert that value into the target link. And finally, look at the satellite table, how we are going to load it. So it is a little bit more complicated. So first we will get the distinct list of satellite records. In a way, it is the combination of each attribute in the table. But please keep in mind, if the attribute is not mapped to target satellite, we will not include it in our distinct combination. Then we will identify the delta record, so it brings us to full and incremental load approaches. So if your ETL process already providing a delta information, then you already know which source data is needed to be compared with the target data. But in case of full load, it will be different approach as you need to identify the change records. Then as a next step, we look up the surrogate key of the parent hub or link for this distinct record. As we already mentioned that the lookup operation depends on your architecture. If you are using the hash key in an environment that referential integrity is disabled, then you don't need to require lookup operation. Then finally you check for changes, so we simply compare if the combination of each attribute for a specific hash key exists in target satellite or not. I would like to remind a point in here. In earlier session we mentioned about hash difference column in the satellite table. The optional hash difference attribute is similar to the hash key in the data vault. It is a hash value of the descriptive data of the satellite entry. Hash difference helps you to compare the rows and identify the differences in descriptive attributes quickly. And adding new satellite entries only when a change has been made to the satellite. It is possible to ignore some of the descriptive attributes by leaving them out of the hash value calculation for the hash difference attribute. It is up to your data vault model if you want to see these attributes in your target satellite tables or not. And finally, if the latest satellite record found and all fields column matching, we will drop this record from the data flow. Or else if the latest record found and that doesn't have a match on all field columns, then we will insert a new row in the target satellite. So these are all main steps when we are loading data vault tables in Enterprise Warehouse. For loading dimension and fact tables, we mostly use the point-in-time tables that reduce the complexity of ETL processes, and we already give an idea in earlier sessions. So thank you for your time.